A truck loaded with cannonball watermelons stops suddenly to avoid running over the edge of a washed-out bridge. The quick stop causes a number of melons to fly off the truck. One melon rolls over the edge with an initial speed of 10 meters per second in the horizontal direction. A cross-section of the bank has the shape of a bottom half of a parabola with its vertex at the edge of the road and with the equation y squared equals 16 meters times x, where x and y are measured in meters. What are the x and y coordinates of the melon when it splatters on the bank? So for this problem, we're going to be using the equation change in position equals initial velocity multiplied by time plus 1/2 acceleration times squared. And we're also going to be doing this for the y direction. So delta y equals VIT plus 1/2 AT squared. And for delta x, there's going to be 0 acceleration, so this part of the equation cancels out. And for delta y, initial velocity is 0, so this part of the equation cancels out, leaving us with delta x equals VIT and delta y equals 1/2 AT squared. So the next thing we need to do is analyze the relationship between x and y, and that's given to us in the form of y squared equals 16x. In other words, y equals square root 16x. And then we can set both of these equations equal to each other, with y being 1/2 AT squared is equal to square root 16 VIT. And then what we need to do is square both sides to get rid of the square roots, and that would just give us 1/4 a squared t to the 4th is equal to 16 VIT. And then we can divide both sides by t, leaving us with 1/4 a squared t cubed is equal to 16 VI. And then we just divide both sides by 1/4 a squared, giving us t cubed is equal to 16 v sub I is equal to 1/4 a squared. Then we just take the cube root of both sides, so t is going to be equal to the cube root of 16 vi over 1/4 a squared. And then you can evaluate this in your calculator, approximately 1.88 seconds. And now we can actually use this time value and plug them into the original equations. So delta x is equal to VIT, and delta y is equal to 1/2 AT squared. So that would be delta x equals 10 meters per second multiplied by 1.88 seconds. And that would give us delta y equals 1/2 times negative 9.8 meters per second squared multiplied by 1.88 seconds squared. Finally, that would give us delta x is equal to 18.8 meters, and delta y is equal to negative 17.32 meters.